Hello everyone, this is Alice Gao. In this video, I will start introducing components of the variable elimination algorithm. Let's look at the first step, defining the factors. A factor is a function from a set of random variables to a number. Formally, let f denote a factor and let x sub 1 to x sub j denote the variables in the factor. A factor is an abstract concept. It can represent a joint probability or a conditional probability. For example, a factor with two variables x1 and x2 can represent one of three things. The probability of x1 and x2. This is a joint probability. The probability of x1 given x2. This is a conditional probability. The probability of x1 and x3 given x2, where x3 is equal to v3. For the third probability, although x3 appears, it is not a variable since we already assigned a value to it. When you are given a factor, the meanings of the values may not be obvious. For instance, if the factor does not represent a joint distribution, the values may not sum to 1. Defining factors is the first step of the variable elimination algorithm. For each node in the Bayesian network, we need to take the conditional probability distribution and convert it into a factor. For example, for the Holmes network, we need to define 6 factors. Let's do an example. Take the radio node in the Holmes network. The node represents the conditional probability of radio given earthquake. Let's convert this distribution to a factor, which should contain two variables, radio and earthquake. With two binary variables, it should have 4 values. Take a look at this factor. The factor doesn't tell us that this is a conditional probability distribution. We can infer it by looking at which pair of probabilities sums up to 1. That's everything on defining factors. Let me summarize. After watching this video, you should be able to do the following. Explain what a factor is. Define factors based on a Bayesian network. Thank you very much for watching. I will see you in the next video. Bye for now.